Hello everyone, I am Deepika Prasad Gajali. I am from the Sri Siddheshwar Women's College of Engineering, Solapur. I am here to tell you about the acid properties in the DBMS. Before we move to the acid property, let's define what is at the transaction. A transaction is a single logic unit of work which accesses and possibly modifies the content of the database. It can be composed or of one or more related operations. Now, what are the four pillars of the readability? First one is the atomicity, consistency, isolation, and durability. Atomicity means the transaction should be all or nothing. The atomicity ensures that the transaction is treated as the single unit that either complete fully or does not complete at all. No partial completion is allowed. If any step fails, then that entire transaction is rollbacked. Why we needed this? Prevent the inconsistent and the half executed operation. Let's take one example. Consider at the online money transfer of the 50,000. Step 1 is inside the transition debit 50,000 from account 1A and credit 50,000 to the account B. If the system crashes after the step 1 but before the step 2, without the atomicity, money is lost. With the atomicity, if step 1 is cancelled, balance remains unchanged. Next, here, the transaction cannot be half done. The system ensures it either commit means 100% success and rollbacks means the transaction not completed at all. Next one is the consistency. The consistency means the data must follow all the rules. Consistent ensures that the transition must follow all database rules such as the data types, constraint, business rule, and the integrity constraint. After transition, the database must remain in a valid state. Why we needed it? Prevent invalid data from the entering database, ensure database accuracy. Let's take one example. A bank rule account balance cannot go negative if the user tries to draw 10,000 from the account that has only 2,000. System will reject the transition because it violates the consistency rule. Another example is that the student register system, the student ID must be unique. Email cannot be null. If the transaction tries to insert a duplicate ID, consistency will block it. Next one was the isolation. Isolation ensures that the concurrent transaction happens at the same time. Do not interfere with another one. Each transaction behaves as it is the only one accessing the data. Why we need it? Prevent incorrect result when the multiple user update simultaneously. Avoid dirty reads, uncommitted data issue, and example is that if the two users trying to purchase the same list product online, the transaction T1 adds item to cart, proceed to payment. The transaction 2 adds the same item. The isolation ensures that which transaction finished the first gets the item, the other gets the out of the stock. Next one was the durability. Durability means the permanent change after the commit. After the transition, the successful finished, it changes become a permanent even if the system crashes, power fails, power fails, database restart, changes are stored safely in a non-volatile storage. Why we need it? Ensures long-term readability of data, protect against the system failure. For example, after a successful UPI payment, the amount is detected from your account, the amount is added to the receiver account. Both entities are saved permanently. Why do ACID property matters? For the data integrity, ensure data is correct, accurate, valid, and not cooperated. Readability means guarantees that the database behaves predictably even during the errors or the system failures. Trust and the concurrency control. The core principle of the acid properties moves the database from the one consistent state to the another. Conclusion: acid property are the foundation of the reliability transition processing is almost all modern database systems. They ensure operations are safe, consistent, isolated, and the permanent, which is essential for making data integrity and the accuracy. Thank you.